13.8 billion years ago, there was absolutely nothing. No stars, no galaxies, no planets, not even space or time. It's hard to imagine, but even emptiness didn't exist. And then, in an instant that defies explanation, everything began. We call it the Big Bang, though it wasn't a bang in the way we imagine explosions. There was no sound, no fireball in space. It was the birth of space itself. An expansion from a point of infinite density and temperature, growing faster than light, not into space, but creating space as it expanded. This was the beginning of our universe, and it happened everywhere at once. In that first trillionth of a second, the universe ballooned from smaller than an atom to something unimaginably vast. The laws of physics we now know were forged in that instant. The energy was so intense that matter couldn't exist in any familiar form. Instead, a seething soup of fundamental particles, quarks, gluons, photons, raced through space. Particles collided, annihilated, and were reborn again in a cosmic frenzy. But some survived. Quarks came together to form protons and neutrons. Within seconds, the basic building blocks of atomic nuclei were created. 3 minutes in, temperatures dropped enough to allow these protons and neutrons to fuse, forming the first elements, mostly hydrogen, with a dash of helium and trace amounts of lithium. But atoms, as we know them, still couldn't exist. The universe was too hot and dense. Electrons couldn't yet orbit nuclei. The result was a foggy plasma, where light couldn't move freely. It bounced endlessly off particles like headlights in a dense mist. For nearly 380,000 years, this continued, until a turning point arrived. The universe cooled enough for electrons to bind with nuclei. Atoms formed, the fog lifted, and light finally streamed across space. This ancient light is what we now detect as the cosmic microwave background, the afterglow of the Big Bang. From this moment of clarity, the universe entered a new era. Tiny fluctuations in density, seeded during the universe's earliest moments, began to grow under the influence of gravity. Invisible dark matter clumped, drawing gas along with it. Over millions of years, these clumps became the scaffolding for galaxies. Giant clouds of hydrogen collapsed to form the first stars. These were not like our sun. They were massive, hot, and short-lived. They burned through their fuel in just a few million years, ending their lives in spectacular supernova. These explosions scattered heavier elements, carbon, nitrogen, oxygen, iron, into the cosmos. The universe was no longer pure, it was enriched. With this new material, second-generation stars formed. Around them, planets began to coalesce from disks of gas and dust. Galaxies took shape, spirals, ellipticals, irregulars, spinning in vast filaments across the universe. One of those galaxies was the Milky Way. In a quiet corner of it, about 4.6 billion years ago, a star was born. We call it the Sun. Around it, a swirling disk of debris formed planets, moons, and asteroids. Earth emerged, a rocky world in the Sun's habitable zone, just the right distance for liquid water. On this blue planet, something extraordinary happened. Life. It began in the oceans as simple molecules learned to replicate. Over billions of years, evolution shaped life into ever more complex forms. Single-celled organisms, plants, animals. Catastrophes came and went. Asteroids hit. Volcanoes erupted. Mass extinctions wiped out most species, clearing the way for new ones. Dinosaurs ruled for over 150 million years before a space rock ended their reign. From their ashes, mammals rose. One lineage of ape learned to walk upright, to shape tools, to harness fire, to speak and think and wonder. Humanity was born. We are creatures of stardust. Every atom in our bodies was forged in ancient stars. And somehow, those atoms came together in a way that allowed us to question our origins. We looked to the sky, puzzled over the stars, created myths, then science. We built telescopes, discovered galaxies beyond our own, and learned that we are not at the center of the universe. We are on a small planet, orbiting an average star in one of hundreds of billions of galaxies. Yet we are also something rare, the universe, aware of itself. Through science, we uncovered deep truths. We discovered gravity, electromagnetism, the atomic nucleus. We split the atom, walked on the moon, and sent spacecraft beyond the solar system. We learned that the universe is expanding, not slowly, but faster and faster, driven by a mysterious force called dark energy. And we know that most of the matter in the universe is invisible to us, dark matter, which does not emit or absorb light, but reveals itself through gravity. We mapped the cosmic web, watched galaxies collide, and glimpsed the birth of stars. Still, the universe holds secrets. What is dark energy? What is dark matter? Did time have a beginning? Will it have an end? We search for answers with the James Webb Space Telescope, particle colliders, and radio telescopes, listening to the cosmos. And yet, as we push the boundaries of knowledge, we are reminded of how much we don't know. We are explorers in a vast sea of mystery. The future of the universe stretches far beyond human time. In 5 billion years, the sun will swell into a red giant, consuming Mercury and Venus and scorching Earth. Eventually, it will shed its outer layers, leaving behind a white dwarf, small, dense, and dim. The solar system will grow cold. Elsewhere, galaxies will continue to evolve. Stars will live and die. Black holes will swallow entire regions of space. Trillions of years from now, most stars will be gone. The universe may enter a phase of darkness, a heat death, where all energy is evenly spread and nothing new can happen. Or it might collapse in a big crunch, or cycle endlessly through expansions and contractions. But for now, in this moment, we are here, alive, conscious, capable of creating art, exploring science, and wondering why. Our story is written in the atoms of our bodies, the orbits of our planets, the fusion in our stars. It is a story of chance, of physics, of time, and of curiosity. We are not separate from the universe. We are the universe, made conscious. A brief spark in a cosmic night, but a spark that asks questions. And maybe that's the most beautiful thing of all. These were not like the stars we see today. The first stars, called Population 3 stars, were massive, hundreds of times the mass of our sun, and burned intensely bright with short, violent lives. They lived for only a few million years before exploding in spectacular supernovae. These explosions were crucial. They forged and scattered the first heavy elements, carbon, oxygen, iron, into space, enriching the universe with the ingredients necessary for planets and life. As time went on, new generations of stars formed from these enriched clouds of gas. Around some of these stars, disks of dust and debris swirled, gradually coalescing into planets. Galaxies began to take shape, vast islands of stars held together by gravity, swirling and colliding, merging and growing. Over billions of years, the universe transformed from a chaotic sea of gas and radiation into a cosmic tapestry woven with stars, galaxies, and structure. In a quiet corner of one galaxy, the Milky Way, our own solar system was born. About 4.6 billion years ago, a cloud of gas and dust collapsed under its own gravity. At its center, the sun ignited into a new star. Around it, leftover material began to stick together, forming planets, moons, asteroids, and comets. Among them was Earth, a rocky planet orbiting just the right distance from the Sun for liquid water to exist. It was a cosmic Goldilocks zone, and it became the cradle of something extraordinary. Life on Earth began in the oceans, possibly around hydrothermal vents or within pools of warm, chemical-rich water. Simple cells emerged, tiny bags of chemistry that could copy themselves. Over billions of years, these primitive forms of life evolved. They developed complexity, structure, and variety. Single cells became multicellular organisms. Life colonized land, adapted to air, evolved sight, mobility, brains. It branched into every niche imaginable. Dinosaurs ruled for millions of years before vanishing in a cataclysm, paving the way for mammals to thrive. Among those mammals, one species emerged with a curious brain: humans. We built tools, created language, formed cultures, and began to ask questions no other species had. Where did we come from? What is this place? We looked up and wondered at the stars. Over time, our curiosity led us to build telescopes and satellites. We discovered galaxies far beyond our own. We learned that we live on just one planet, orbiting a typical star, in a spiral arm of a galaxy that's just one among trillions. In the last century alone, our understanding of the cosmos has exploded. We've learned that the universe is not just expanding, but accelerating in its expansion. Something unseen, dark energy, is driving galaxies apart, faster and faster. And something else, dark matter, makes up most of the mass in the universe, though we can't see or touch it. We don't know what these forces truly are, but they shape the cosmos around us. We've also peered into the distant past by looking deep into space. Because light takes time to travel, the farther we look, the further back in time we see. We've seen galaxies as they were, billions of years ago. We've witnessed the birth of stars, the death of others, and even the collision of neutron stars sending ripples through space-time, gravitational waves that we can now detect. Meanwhile, here on Earth, we've begun to explore. We've landed on the moon. We've sent robots to Mars and spacecraft to the edge of the solar system. Probes like Voyager carry messages to the stars, hoping one day someone or something will find them. We're searching for signs of life on distant exoplanets, scanning atmospheres for water vapor and oxygen. We haven't found other life yet, but the search has only just begun. Yet even with all we've learned, the future of the universe remains a mystery. Our sun, like all stars, is finite. In about 5 billion years, it will swell into a red giant, possibly engulfing Mercury, Venus, and maybe even Earth. After shedding its outer layers, it will leave behind a glowing core, a white dwarf that will slowly fade for trillions of years. Other stars will follow the same path. Some, much more massive, will end as neutron stars or black holes. Over unimaginable timescales, galaxies will collide, merge, and fade. Star formation will slow and eventually stop. The universe will grow darker and colder. Black holes will be the last remaining engines of energy. And then even they will evaporate. This long, slow decline is called the heat death of the universe, a time when all matter is decayed, all stars extinguished, and energy spread so thin that nothing can happen anymore. A cold, black, silent void stretching forever. Or perhaps the universe will collapse in a big crunch, or tear apart in a big rip. We don't know for sure. The end is as mysterious as the beginning. But here's the wonder. For a fleeting moment in cosmic time, we exist. We are stardust given consciousness. The atoms in your body were once inside stars that lived and died billions of years ago. You are, quite literally, a piece of the universe trying to understand itself. And that makes your life part of the greatest story ever told. And it's only just begun.